Okay, on this one, we want to do the exact same thing. They gave us f prime. And so we want to do some plus minus charts before we even read anything. So I'm going to do f prime and f double prime. Our domain is negative 7 to 7. So write these down for yourself on a test, on homework. I always do this. Now I'm looking at where my derivative is 0. So my derivative is 0 at negative 5, at negative 1, and at 5. While we're at it, it is positive, negative, positive, and then positive again. So these are just telling me the answers every time, like what my slopes are, what my first derivative is. Now I'm going to look at what my first derivative is doing to tell me what its derivative is. So this is like the second derivative. All right, so it looks like this derivative is 0 at negative 3, at 2, and at 5. And also it tells me that it has a vertical tangent at 3. So what that means, it also could possibly be a point of inflection, because when it has a vertical tangent, that means your derivative of your derivative is undefined. And remember, points of inflection and critical numbers can happen when, so concavity can change when your derivative is undefined or when it's 0. So all of those are important. It tells me horizontal tangents at negative 3, at 2 and 5, and a vertical tangent at 3. That's how we find our candidates for points of inflection and critical numbers. All right, now, how do we know what the derivative of the derivative is? While this is decreasing, its derivative will be negative. While this is increasing, its derivative will be positive. While this is decreasing, all of the slopes of the derivative would be negative. And then they continue to be negative after 3. And then this is increasing, so its derivative should be positive. Remember, we have a vertical tangent at 3. All right, so now we're ready to answer all these questions. Please, please do this first. It's very important. Have this data all ready to go, and then you can look at it for your answers. All right, so let's change colors. All right, relative minimum. All right, so minimum is going to happen when you've gone, here we've gone up, down, up, up. So when you go down and go back up, that could be your relative minimum. We know our graph has gone up, down, up, up. So relative minimum is at x equals negative 1. How do we know that? Negative 1, sorry, make sure you make it negative. I know that f prime of negative 1 was 0. And I know that f prime changed from negative to positive at x equals negative 1. And now we're doing a relative max. All right, relative max can occur at negative 5 because it went up, down, and then up, up. So it's only relative max, not absolute, but relative max. Occurs at x equals negative 5. We know that f prime of negative 5 was 0. My derivative quite literally was 0 at negative 5. Right here. And we knew that our derivative was positive and then negative. So f prime changes. Again, make some more room. You've got room down here to write. Changes from, I write a lot neater than I am. That looks awful. Please don't squeeze all this in. F prime changes from positive to negative. I'd write out the words at x equals negative 5. All right, so that's B. Now C. Find all values for where your second derivative is less than 0. Well, yay, I've already found that. My second derivative is less than 0 from -7 to -3. Be careful. My second derivative is negative from 2 to 3, and then from 3 to 7. Because we knew at 3 it had a vertical tangent, so technically it's not negative during that time. Right there. And I would go on and say how I knew that. I knew that because f prime was decreasing on these intervals. Spell it correctly, on these intervals. So since this was decreasing, my derivative would be negative every time it was decreasing. All right, and then on D, at what value of x does it have an absolute maximum? Well, what do we know about this graph? We knew this graph went up, down, up, up. So it could be at one of these two places. It could be at it could be here or here. It could be at your relative max or your absolute max. So the question is, which one's bigger? It could be at -5, or it could be at the end at 7. You always consider your endpoints. Again, this graph went up, down, up, up, but we don't know how far up it went. So there's going to actually be more about this later in the year, but for now, what you need to realize, and I'll teach you more about this later, is this displacement here, or the magnitude that it went down, is reflected. Even though this is your derivative is negative, there's a direct correlation we'll talk about later, that the area of this is less than all of this area that it increased up to 7. Now, I know I'm looking at the derivative. I'm not looking at the original. But the magnitude enclosed underneath the derivative helps you know that it went up a lot more than it went down. How would you say that for now until we know more about it, like why that's true? That's like a really profound thing we'll go over. So you want to say, first of all, you want to say what you're looking at to get as many points as you can. So what are we looking at? I would say the absolute max occurs, so give the candidates, and that gets you a point probably, at x equals -5 or at x equals 7. But I know that f of -5 I'm sorry, I was just looking at what I said. I know f of negative, well, it could occur at the endpoints, but now I'm thinking about what I wrote. I actually had ruled out -7. I already knew that at checking this endpoint at -7, I knew that f of -5 was greater than f of -7 because it increased from -7 to -5. This was probably not necessary because we've established we're really only looking at these two, but I was just maybe over-explaining. Now I know f of 7 is greater than f of -5 because the derivative f prime shows the magnitude of the negative change is less than the positive change. And I probably need to say from -5 to -1, actually. The magnitude of the negative change on -5 to -1 is less than positive change on -1 to 7. All right, and since that is true, x equals 7 is the absolute, we'll say f of 7. F of 7 is the absolute maximum value. And I always want to go back and see which x does it have an absolute maximum. So I think I'll say at x equals 7, it reaches its absolute maximum because it didn't ask for the value. Absolute max occurs at x equals 7. So just a couple more notes on this that are we'll be thinking about all year, and I'll be explaining why it happens. But this right here, while your derivative is negative, that means it's not decreasing very long. Whereas here, see how long it's increasing and actually how far it goes up here. Like, let's see how I want to say it. This has to be more than that. It's pretty far away from the axis. So you'll see, like, well, you'll think about this picture later, but that's reflective of how much it could be growing. All right, now let me find the other one, AB6. All right, and I think this is the one we haven't done. Yeah, okay. So AB6, all right, of course I'm going to do my charts first. F prime, I'm going from -3 to 3. Where is my derivative negative? And by the way, I have the derivative. My derivative is negative at -2, 0, and 2. This is positive, negative, positive, positive. And then my derivative, go ahead and do it before you start the problem, please. The derivative of the derivative would be 0 at -1, 0 at 1, and 0 at 2. This is decreasing until I get to -1, so its derivative will be negative. This is increasing, so its derivative will be positive. Decreasing, increasing. Okay, so now let's see what the questions are. Relative maximum. Relative maximum is going to occur at x equals -2. And we want to justify our answer. Oh, wait. For what values have a relative max? So we'll do the relative max first. Don't try to squeeze it all in right here. Use your light paper. Relative maximum x equals -2 because we know our function increased and then decreased. But really, I want to say by what I was given because f prime changes from positive to negative at x equals -2. And f prime of -2 equals 0. You want to know where it's 0 or undefined. All right, so you want to establish a critical number. All right, relative minimum. So it has a relative minimum. Let's see where it changes from negative to positive. So at 0. All right, so relative minimum at x equals 0. F prime of 0 equals 0, which makes it a candidate for a critical number because this is the derivative we're looking at, and our derivative changes from negative to positive at 0. So I'll say because as f prime changes from negative to positive. Doing these charts first before you ever start really saves you from overthinking things. If you look at this derivative and go, what is this? It is positive, negative, positive, positive. Okay, and then you've already thought about it. While this is decreasing, its derivative is negative. While this is increasing, its derivative is positive, decreasing, increasing. And then you've already thought it all out. All right, where's it concave up? I've got it. Concave up from -1 right in here to 1. And it's also concave up from 2 to 3. Concavity, I'm looking at my second derivative. Now, how did I know that? Even if it doesn't ask me, I knew that because that's where f prime is increasing on these intervals. All right, so again, I'd already decided, I already knew the answers. All right, now, why did you know that? You knew that was concave up because we knew our derivative was increasing at that time. Now use the information to try to draw a graph. All right, so let's get some room here. What else do we know here? We know f of -3 is 0. And we're only going to 3. Don't ever graph beyond the domain that they give you. All right, we know that we have a maximum at -2. We don't have any kind of value at -2. So we also know I increase and then decrease. And we know it's concave down. That's important. Until I get to concave down till I get to -1. So I'm going to make it concave down, and there's a relative max right there. All right, now I have to go concave up between -1 and 1, but I have to decrease until I get to 0, and then I've got to increase. So let's see how I'm going to do that. I've got to make it concave up while I'm decreasing and then increasing until I get to 2. So I'm going to go down, and here's concave up from -1 to 1. And I've drawn on this so much. This is -1 to 1. It's concave up. And I should have decreased until I got to 0, and then increased until I got to 1. That's +1. Now it's got to be concave up. It's got to increase from 0 to 2, but I'm concave down until I get to 2. So I've got to increase, but make it concave down at 2. So I'm going to make it concave down right here. Concave down. And then I've got to still increase, but turn concave up. And I don't know that it hit 0, 0 right here. And you also don't want those arrows there. Anyway, that's a good representation of it. And they never asked us for absolute anything. Okay, so that's a possible graph of f. There was something else I was going to say here. One thing to think about is which one would be the absolute maximum if they asked us. Would it happen at -2, or would it happen at the very end? Because we know this graph increased, decreased, and then increased, but did it increase higher than this or lower than this? Well, one thing we're going to be looking at is this displacement. Do you see those are about the same? That means it must have decreased as much as it increased, so it came back to where it started from, but then it went a little higher. So if they'd asked me, I would have found some way to say, I think that the absolute maximum is at x = 3.